Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we will continue with chapter 5 today with the topic work, energy and power. Okay, what do you mean by work? Okay, the work is energy which is transferred by the force. So what is energy? Energy is the ability to do the work. Okay, I will explain this later. What is the definition of work and energy? Or maybe the relation between these two and also the power in the next subtopic. So in this video, I will only share how to calculate the work. Okay? If the point of application of a constant force of F newtons move through a distance S meters in the direction of the force, then the first work done. Then the work done with a then the work done is defined to be F times S joules. Okay, so we know that we will only have two things that you have to consider. The first one is the F, which is the unit would be in Newton, and then the distance, the unit is M. Okay, it is Newton meter, or simply you can use joules. Okay, or we represent with a capital J. So if let's say we have an object with a mass of M, and then there is a force of F with a distance, it is pushed, the box is pushed with a force F in a distance through a distance S meter. So the work done is the force times the distance, and the unit will be in joules. Okay, it can move this one, it can move horizontally or vertically. So if let's say vertically, then the work is done against the gravity. So you also have a mass with maybe it moves up. So in order to raise a mass of m kg vertically at a constant speed, a force of mg Newton must be applied vertically upwards to the mass. In raising the mass a distance of s meters, the work done against gravity will be mgs joules. Because there we have a mass here, mg, and then it moves. The force is mg. The formula is still the same, which is the force times the distance. So because we have mg, the force would be mg, and then the distance would be, if let's say it moves s, then the distance would be s. Or maybe because we move it vertically, so normally we can say the s or the distance is the height. So we can use mgh. Okay, please take note that the force, even the object is moving up, we take the force mg because it moves in a constant speed. Okay, it applies Newton's first law. Okay, we look example 1. Okay, find the work done against gravity when an object of mass 3.5 kg is raised through a vertical distance of 6 meters. So, as I said, the work done is F times D. And since it is moving vertically, we can use mg D or mg height. So, the mass is 3.5. and then your G is 9.81, and then the height is, this one is 6 meters. So you get your answer would be 205.81 joules. Okay, since this book is using the gravity is 9.8, so the calculation would be a little bit different. We just use 9.81. So if let's say 9.81, we will get 206.01 joules. Okay, we move on to example 2. Okay, this object is moving horizontally. A block of wood is pulled a distance of 4 meters across a horizontal surface against resistance totaling 7.5. If the block moves at a constant velocity, find the work done against the resistance. Okay, if let's say, if you notice, we use the word against here. Against means berlawanan. So berlawanan dengan gravity. So kita akan ambil this one. This is the force. Okay, this is the gravity. Okay, and then this is the force against the gravity. Kalau if let's say this one against resistance, against resistance will always be the opposite side or a side of the direction. So if let's say this is the direction, against resistance means berlawanan dengan resistance yang opposite lah. So if let's say it is given here 7.5, yes, we still consider F here, which is F times T. We still consider 7.5 and the distance is 4. So this one, your answer would be 30 joules. So when the word is against resistance, maksudnya berlawanan. Sebab tu kita ambil F. So it doesn't means that 7.5 is moving backward here, moving to the left. Kita ambil negative. No, we will not take the negative, but we will take the against resistance. Okay, and then we move on to example 3. Okay, our horizontal force pulls a body of 2.25 kilogram a distance of 8 meters across a rough horizontal surface. Okay, this one, the question is different because there is a rough surface. When you have a rough surface, means you have a friction. Horizontal surface, coefficient of friction 1/3. The body moves with a constant velocity and the only resistance is that due to the friction. Find the work against resistance. So if let's say just now we have against gravity, the first example is against gravity. Example 2 is against resistance. Example 3 is against friction. Example 1, against gravity maksudnya dia bergerak secara vertikal, atas ke bawah. Example 2 dengan 3, against resistance, against friction, dua-dua bergerak secara horizontally. So apa beza against resistance is that dia akan automatically, it will straight forward give you the force. So force dia 7.5. Dia akan bagi direct. Kalau friction, sama juga, dia akan bagi direct what is the friction, tapi we will still consider the force ke arah opposite direction daripada dia punya pergerakan kan, opposite direction. Tetapi mungkin dia suruh kira dululah what is the friction. So you have to calculate the friction first. The concept is still the same, where work is equal to F times T. But now F tu, force tu, kalau example tu kita terus ambil lah dia punya nilai. But if let's say against friction, mungkin you have to calculate first. So F tu adalah mu R. Okay, so kalau misalnya in example tu, F ni dah bagi. But if let's say in friction, untuk soalan yang ni, mungkin dia suruh cari dulu. So if let's say F digantikan dengan mu R. So you have to find mu R first. Okay. So mu we have already found mu. because it is given in the question 1 over 3, but R is not given. So R here, the object is doesn't move up and down, right? So R should be the same as the vertical, the mass here, mg. So you just substitute 2.25 g here. So, and then your distance would be 8 meter. So your final answer would be 58.8 joules. But this one, the example, if let's say you use 9.8, but if let's say you want to use 9.81 times 8, so your answer would be a bit different. 58.86. Okay, we will continue with the exercise 11A in the next video.